Hello, everyone. Very good afternoon. I really enjoyed the lightning talks. Thanks, everyone. And I hope you guys are all slightly awake. So this is a slightly off the center topic. So this is more about DevOps rather than Ruby or Rails per se. So I'd like to know who all are already familiar with Docker, have tried out, or just know what it does and stuff like that. Okay, not too many. Sorry about that. So I've been a web developer for quite some time, and a good part of it is Rails. Actually, I actually remember the days when the 15-minute video came out. So all through these years, I've also kind of ended up setting up servers for the Ruby teams that I worked with, and I've been a Linux guy for as long as I can remember, as in the professional life of mine. And so I thought, so lately I've been observing what's happening on the production side of things. So I guess a bunch of you, so how many of you have set up your own Rails servers, maintained them? Oh, quite a few. Okay, then this should be relevant to what you're doing. So the point of, so we're going to talk about zero downtime deployments with Docker. So the point of this is, so what is Docker? So the first thing that Docker does is it basically commoditizes Alexi. Alexi is Linux containers. So the containers, you can think of them as something like chroot jail, change root jails you have in Linux. So what it basically does is it gives you a separate folder as a root, and you can run off your processes from there, and all the children are only allowed to access that part of the directory as a root directory. A container extends this concept by giving you isolation on memory level. It gives you isolation on network level. It gives you isolation on hard disk level. So Alexi is a fairly old technology in Linux, but it has been mostly in the realm of people who understand Linux pretty well, or sysadmins who are trying to achieve something on the production side. So Docker basically makes this accessible to all of us. So it makes portable deployments across machines possible. So you can basically have I have, suppose, a Vagrant box which runs raring install, but you can also you can actually run production systems, production installs out of say 12.04 precise. So you get a lot of flexibility of moving your production images around. So there is efficient and quick provisioning. So it saves on disk how much disk it uses by doing copy on write installs. I'll talk about a little bit later. It's near native performance. It's basically process virtualization. So you're not doing hardware virtualization, or you're not trying to support different OSs and stuff like that. So the speed at which your Docker instance boots up is very quick. So you almost have no overhead at all. So it also does Git-like versioning of images. So you have basically a base image which says Ubuntu, and you can install something like Emacs on it, and you can commit it, and it'll save it, and it'll make it into another image, which will also, I'll show you a little bit more about that. So that enables a lot of reuse. So you can basically push these images to a public repository that Docker maintains, index.docker.io. So if they're public, if they're open for sharing, so you can push them out there, and people can use your own configuration, however you've configured your image. And the major difference between how Alexi operates, or how Alexi is thought about, and how Docker encourages you to think about containers is that, so Alexi was initially thought of as lightweight servers where you install basically everything and put them up and treat them as just like any other server. Docker kind of encourages you to look at containers as an application. So you install, say, your database MySQL in one container, you install your app server in another container, you install your YOLODB, so in another container. So what is Alexi? I actually wanted to take out this slide. Probably it's a little too advanced for this talk, but I'll try to cover this quickly. So at the basic level, it provides OS level virtualization for Linux. Compared to, say, what VirtualBox does for you, or KVM or Zen. So these are all hardware virtualization. So OS level virtualization, much faster, much lightweight, perfect for production deployment. So it basically does this. Alexi basically provides you own process space, own network interface, and your own init framework. So you can be running on Ubuntu, which uses Upstart, and your container can use systemd. That's not a problem at all. So the basic isolation is achieved with C groups. C groups are control groups. So what C groups gives you is that it lets you put limits on the resource usage, basically, whether it's network or your disk or your process usage. So C groups gives you this nice little interface where you can do. This is definitely in the Linux geek territory. You don't have to worry about that. So the only catch is that it shares the kernel with the host. So you can do stuff like having an x64 image and put it on i36, or vice versa. So that's pretty much the only catch here, and it's probably not much of a catch at all. So a typical Docker image kind of looks like this. At the most basic level, you see the kernel, and you have C groups, you have namespaces, and device mapper. So Docker kind of achieves this Git-like versioning through a unioning file system. Right now, Debian-based installs use AUFS, which is quite popular, but it has some limitations, which is it's integrated into a Debian kernel, but Debian-based distros kernels, but it's not really available in others like CentOS and Red Hats of the world. So recently they've created a storage driver which kind of lets you swap out AUFS with the device mapper, and there's plans for integrating ZFS and BTRFS and stuff like that. So beyond that, you see the base image which is shipped out of Docker registry, and you also have images. So I install Emacs and commit it, it becomes a read-only. So rootfs is basically read-only, and once you boot up that container, you will get a writable part. So once you commit it, it will become again read-only. We'll go through that workflow fast. So the basic workflow, we'll do it now again. So you basically pull Docker images from the public registry, and you run it on your host, and you add your own changes on top of it, push it back to share them, or you could also build it from the ground up using dbootstrap and tools like that. So you also have a Dockerfile which lets you build your own images. Apart from that, you can set up a private registry. So the idea of private registry is that you have your own work groups and you want to share these images within your company, and they're not really useful for the public usage. So this is where a private registry comes in, and this is just a simple Python app. You can run it on your own server and set it up. Or you can also sign up for something like Quay.io, which also lets you push to you can have your own account, pay for it, and push your private images there, and it's locked down. So before we go into the Dockerfile part, so let me show you a simple workflow. So you have images. So you can probably ignore a bunch of these. Look at the last ones, which is basically, should I move that a little bit? Oh, that's not too good. Okay. So at the most basic level, when you pull from Docker, say, so it will try to, so it's not going to pull anything really. It will just check for the layers that are available on my system, and it will just adjust itself. So you see several layers there. So if you look at the Ubuntu part, it's actually, the Ubuntu image is actually comprised of Precise and Quantal. So you can use any of those to kick off your container. So kicking off a container is probably as simple as and you have to give it a. I'm taking the Ubuntu image, a base image, and I have to give an entry point. So it will drop me into a root prompt, and basically I can do. I can run apt-get updates, and I can install my own stuff. I'll just install a small, very tiny package, so in the interest of time. Wow, that takes. So the base Docker image is pretty much very stripped down. You won't have most of the components that you would need. So the idea is that it should be very lightweight to deploy it, and you can basically add your own software on top of it and commit it and push it up. So let's say I install our Nano editor, right? I hope that shouldn't take too long. Yeah. So you have Nano here, and if I switch to the other window, you can see. Docker PS. So among the other ones, you can see the last one which is being run here. And if I actually use Nano there, you can see Docker. So each of the containers will have its own names. So you can do cranky. You can also set the names, which is a recent feature. But otherwise, it will just generate. Sorry. So it gives you what is happening inside the container. So you have a basic idea of what's running inside the container. So you can also commit this. So you exit it, and you see. So cranky query is on there, so you can do something like Docker commit cranky query. Oops. Sorry. So you can commit it, and it will show up in your images. I have to give it a name. Cranky query as Vamsee Nano. So Docker images. You'll see the one on top. It has Vamsee Nano. So and you can push it. You can push it to the public registry. The public registry kind of looks like this. So you can search for your own whatever images that you might need for your deployments and stuff like that. So I've been playing around with it a little bit and stuff like that. So this is the public repository. You can install the same thing on your private servers and secure it from outside, and you can have your own image. So that's basically the workflow that you would work with. And there's a second part to it. What I've done so far is the manual. So I've logged into a container and I've installed stuff in it. So you basically automate it with something called the Dockerfile. Oh, sorry. So Dockerfile, it's very similar to what you have rake file or make files in your projects. So it's a default way to build it from base image, basically a glorified shell script, but definitely easier to maintain. And you have directives like from, run, command, expose. So from is basically which, based on which image do I want to build my Docker. And you have run, basically has apt-get install commands, whatever I've done manually. And command and entry point are very similar. So I've entered into the container through bin bash. So I've basically put that in entry point. And command is what passes, you pass some options into that. So I'll show you a Dockerfile anyway. So that should put all this in context. So you can even add files. You can copy config files from your host system into your container. You can have volumes. Volumes are basically mount points. You just mount a whole directory as either read-only or read-write. It's up to you. And on the whole, there are about a dozen commands. It's very simple to get started with, no nonsense, and doesn't need a lot of time to learn the whole thing. So, and you can create your own base images using dbootstrap, and in CentOS, dbootstrap is basically a Debian tool where how you build a base image, but in other distros you have you can do it with other tools. So zero downtime deployment. So why do we need them? So the most important part being you have things like continuous delivery and continuous deployments, right? So they're subtly different from each other. They're very similar concepts, of course. You have continuous delivery where you send stuff, you deliver your software on a regular basis, and you have tight communication loops with your clients and all that good stuff, agile stuff. And continuous deployments is basically taking it one step ahead. I think Shad did a really good example of that yesterday. So, instead of making your deployments, say, once a week or once every few days, the idea is to make them as continuously as possible with least amount of angst around making deployments. So you basically have, I'm sure you're all used to long deploys in Rails. Migrations, when migrations are happening, you're changing the schema. You usually put in a maintenance page, and when the other request comes in, if you don't put a maintenance page, you can get some errors and stuff like that. And obviously, about asset compilation, it takes way too long. So, but these problems are not really limited to Rails per se. I'm sure you have the same issues when you're deploying a Django container. So Docker is basically framework agnostic. You can run any apps on it. And so I'm trying to lay out a problem. So there are two parts to this problem. So one is with migrations and without migrations. Without migrations, it's usually a little easier because you don't have to worry about making sure the databases are in sync and stuff like that. So with databases, it's a more complex scenario where you have to take a master DB, slave DB, make sure they're synced, and you have something like Zookeeper kind of keeping track of who's master, who's slave, and you switch. So I'll try to walk you through the simpler case. So we can extend this to DB level. I don't think I can cover the DB stuff here. So you basically have HA proxy. HA proxy is basically a reverse proxy, but on steroids. So it's a load balancer, to be exact. But what it does is very similar to what Nginx does for you. You have like multiple instances, and they're running on different multiple instances of your app server. They're running on different ports, and basically Nginx, once the request comes in, Nginx will do round-robin allotment of the servers. So HA proxy does that, but also a lot more. It also lets you do funky stuff like what I'm going to talk about. There's a backup server and active server which you can use cleverly to do zero downtime deployments, but it also has, if you have time, I would suggest you go through the configuration file, which is very dense and long, but very interesting stuff. So what we're going to use of HAProxy here is that you have basically you can set up two types of servers, and there are like a bunch of active servers and there are like a bunch of backup servers. And the idea is that the backup servers are not used until all the active servers are down, right? So the request won't come through to backup servers until all the active servers are down. So what we are gonna, how we're gonna use that? Sorry, the slides are very basic. So, so you basically kick off the deploy, kick off the image build with Docker, and you take down the backup servers. At this point, your HAProxy is still serving from your active servers, right? So. So now you bring up the new backup servers with your new image, which is just being built when the deploy happened. And then you take down the active servers. So after all the active servers are down, the request will come into the backup ones, right? So which is now serving your new code, which has just been deployed. So after that, you restart your active servers, you're back to normal again. So at the most basic level, so at least you will definitely won't be able to do migrations with this setup. You have to go a little bit advanced for that, but at least you will be able to avoid frustrations with stuff like long asset pre-compilation, long deploys that you usually get. So let me walk you through the whole thing quickly. So I was actually quite upset that the pamphlet which is being given, which had shortcuts for Sublime and Vim, but it doesn't have shortcuts for Emacs, which is, I object. So the idea is, okay, let me start you off with the simple Dockerfile. So this should, oh, okay. Let me restart it. I'll just show you on my this thing. I think this is a lot more easier to show you. So app server, you have Dockerfile. So at the most basic level, I'm picking it up from the Ubuntu image and basically running some updation of my sources list. And you have apt-get update, apt-get install, y. So let me run the deploy first, and then I will talk about this because I don't think we'll have enough time to actually wait afterwards. Okay. So this will run the deploy process in the background. Let me talk about what it actually does out here. Oh. Okay. Okay. So let's get back to our Dockerfile. So what it does, this is almost like a shell script that you use for everyday automation. So, but it adds a little bit more fun to it, I guess. So what I'm doing is pretty straightforward. I'm installing chruby. I hate RVM, especially for production. It sucks. I mean, yeah, there are other opinions about it, but at least I've thought it's the easiest way to get started. So I'm basically installing some default gems like Bundler and Puma, and I'm installing other dependencies. So the reason I'm actually splitting this into two Docker files, so you'll also have stuff like so what I'm doing here is that, so when I'm doing actually a deploy, I'm only running this. So I'm picking up, I'm installing all my dependencies in my earlier image, and I'm just reusing it for deploys because I want them to be pretty fast. So what this does is pretty simple. It copies over the database configurations, and it does a bundle and does a DB migrate. I'm just using SQLite here, so yeah. It exposes a port. So how the containers talk to each other within a Docker in your host is that through exposing these ports. And like I mentioned earlier, my entry point is basically I'm starting Puma there, and I'm running it in a daemon mode. Yeah. So if you look at the if you look at the deployment, oh sorry. Yeah. So I don't know how much of this actually makes sense. I'll just show you the deployment code. The cap file, so that should make a little bit of more. Okay. Okay, so if you see at the bottom, you see that I'm just doing a bunch of stuff there. So I'm linking from my current deploy to the Vagrant, the Docker container build directory, and I'm starting from the backend servers. So I should also show you my HA proxy configuration. So it starts with your ports set up, and you actually search for those Docker containers and take them down. So the build takes a little long, so I've kind of commented it out for now, but I can show you outside if you want to see how that works. And it's pretty simple. So at the end of it, I'm just restarting all my containers. So you can basically look at them here, Docker PSA. You'll see that these top ones are only up for 2 minutes. These are recently deployed. So all through, if you look at your HA proxy page, so you basically have 2 active ones here and 2 backup servers here. So and I also should show you the HA proxy stuff, right? So you can pretty much ignore all this stuff. The most important part is the last 2 ones. So as you can see, the Web 01 and Web 02 are active servers, and Web 03 and Web 04 are backup servers. So that's all it takes. So you can basically segment your servers like that and go at it. So that's basically it. So I hope. And a couple of helpful links. Sorry if it's not very visible. There's docker.io where you can find all the documentation and stuff. There's HA proxy. Go look at it if you're doing deployments through your regular day-to-day developer life. This is a life-saving tool to learn well. And there's Dockerbook. It's written by James Turnbull, one of my favorite technical authors. He's written ProPuppet, which is still quite one of my favorite books. And if you want to know a little bit more about the Linux part of what Docker does, like the internals of Docker, you can listen to Jeremy Patazzoni, who's part of the Docker team. So he's given a really good talk, in-depth talk about it at Yandex conference. You should look at the video. And there are like a bunch of tools you can probably look at. There's Doku, which is a PaaS. PaaS is platform as a service. What Heroku does, you can build your own Heroku with Docker. And Flynn.io. CoreOS is also very interesting tool. CoreOS kind of bundles Docker with a service discovery thing, kind of like Zookeeper, but it's called etcd. and it bundles systemd as the init framework. So if you're into deployments, this is a very interesting ecosystem to look at. And Quay.io I mentioned. You can basically upload your private images there and get started. So they're like a bunch of tools. I don't know if I have any time for questions, but you can catch me. Sorry, but I'm available. You can catch me anytime. Thanks a lot.